Hey, everybody, and welcome to episode 435 with Smart Buildings Academy. This is Friday, June 23rd, and today's topic is Highway Heroes, Untold Stories from a Traveling Building Automation Repairman. That's me. I thought about this for a long time. What should I share? What kind of story should I share? And I thought, what I really need to do after I show you a few things and tell you a few anecdotal stories is show you some of the troubleshooting process I went through, because that's really what I would like to share is the instructive part of this. And my audience today should be people who are learning how to do spear catching. That's what they used to call me. Schneider Electric called it smoke jumping. The idea is that you may, on occasion, be sent to something to solve a problem that others have not been able to solve. And the problem with that is the more you do it, the more you'll get to do it. So let's hop in and talk about some of the adventures I've been on and maybe what I learned from it. Um, Let me start with a place in St. Louis. I need to be careful how I describe it because I'm not supposed to mention the names of companies or controller brands, things like that. I was invited to go to an executive hotel where they wanted to improve their energy efficiency. And they had already had a couple of technicians go out there and try to build schedules and you know figure out how much water they're using per year, per month, per day, per week, how much electricity they're using, how much gas they're using, things like that. But it just wasn't working. Something wasn't right about the setup. So I was asked to go out there and look at it, and I did. And this BAS system, building automation system, communicated on ArcNet, um, which should tell you it's an older system. And what was happening was when they were going into occupancy mode or a special schedule, or they were trying to save energy by at a certain time of day change set points in certain things and have certain zones go unoccupied, it just wasn't happening. The building wasn't behaving at all. So I started crawling through the system and looking at it, and I discovered that the network itself was kind of messed up. I found that they had 4 repeaters, and each repeater had 4 circuits going out for every circuit that came in, and nothing had end of line terminators on it. So I traced everything out and put end of line terminators and terminated, but it was still having trouble working in certain zones. So I did more digging, and I crawled up in the ceiling, and I opened up boxes and looked to see how they're set up. And I saw that the ArcNet network had been daisy chained from one box to another, but every now and then, one of the fan power boxes or a VAV box had been T-tapped and run over to yet another zone to run those boxes. Well, in ArcNet, you can't star an ArcNet. You have to do a linear bus. So we solved that. We re-daisy chained. I had to put a couple more repeaters in, put end of line terminations on those. And then we found even more problems. And those boiled down to maintenance issues. It looked like the maintenance company wasn't doing their job. And I hate to say that, but it's true. The maintenance people were pencil whipping their preventive maintenance routines. They weren't actually changing filters. They weren't actually testing valves for operation. They weren't actually checking dampers, things like that. So the lead technician for their maintenance crew and I went through every device in the building, and it was a pretty big building. We went through every device in the building, and we made sure that the actuators worked. And if they didn't, we replaced them. We made sure that all the hot water valves were working, made sure the boiler plant was working. When I got to the boiler plant, the design, the as-built drawings showed that it had a bypass loop for when temperature was satisfied, but there was no actual physical loop. So what we did, we had a black pipe guy, because this was a black pipe system. We had a black pipe guy come in and put in the bypass loop. We put the three-way valve in. We put the actuator in. I wrote the software for that, and ultimately we got it working. Other issues I found were software problems. I found, well, I'm going to be very honest with you. The software didn't work on quite a few of their applications. They had a few hundred pages of software, and maybe half of it worked. They wrote the software, but they didn't test the software. So I went through and rewrote the software. And then I ultimately found that their scheduling process wasn't very good. So I corrected that. And at the end of a year, it took over a year in 2007, took over a year to correct all the problems we found, just so this company could go on a LEED certified energy conservation program. They wanted to get recognized by LEEDs for having done energy conservation. At the end of this process, after everything was said and done, I explained to the engineers and I explained to the maintenance department, and we had classes on how to do maintenance, how to check this system to make sure it's working, how to check for drift on the set points. They weren't logging anything, they weren't trending anything, so we built trends and logs, and we modified the schedule successfully so that at the end of the whole process, this company was able to save, and this is documented, the company was able to save 30% water consumption per year. They were able to save 20% electrical consumption per year, and they were able to save close to 20%. I think it was around 18 or 19% of natural gas per year. The whole goal from the start was to accomplish that. The bid for the job was a week, maybe a week and a half. It took a year of correcting the building before we could even do that one job. So that's an example of one thing I went on. Recently, I was asked to come look at this. I was at I can't tell you where I was. This is a famous baseball stadium. They had just put a cooling tower on the top of the roof where the press box is, and they were having trouble making it work. And so several people had been out there, and ultimately I got called out there and was told, David, to go find out what's going on. So I got there, and that's the first thing I saw was this panel, but it had all this stuff coming out of the gutter. Well, we cleaned it up. We got everything working. We found pump problems. We couldn't get to analyzing why the pumps weren't pumping water to the cooling tower on the roof until we could clean this up. So we spent a week cleaning this up and then going through all the software and making sure the software works. Ultimately, what we found out was the pumps weren't sized properly, and the impellers weren't sized properly to pump the water. So we had to replace the pumps with larger, more robust pumps. That's just yet another one. Now I'm going to show you this one. This is from a famous brewery. I was asked to go out there and see what the problems were, and the battle cry from the maintenance departments was, it's the BAS. The BAS is messing everything up. Nothing's working because the BAS is broken. And in part, that was true, and that was what they were used to doing over 20 years. This BAS system had been installed starting in the late 80s, and moving forward, it had several generations of this brand company's controllers in it. And they had trouble communicating. They had trouble doing what they were supposed to do. Well, this particular unit wasn't behaving properly, and I went up and looked at it, and this is the first thing I saw was filters that are rated for indoor use were, what the guy did was he drilled and mounted some brackets. so he could put filters on the outside of the unit instead of on the inside where they belong, because he frankly got tired of crawling around inside the unit. So he put brackets up and he put indoor air filters on an outdoor application, and he turned the rain bottom upside down. So we spent a little while repairing that, and we put the right filters inside the unit where they belong instead of on the outside. The reason I'm showing you this is that was fairly typical of what I ran into at this particular brewery. As a matter of fact, where they build their cans, where they make their cans, um, they had 27 makeup air units on the roof. And for some reason, over half of them weren't working. And of course, it was a BAS problem. So I got called. I went up to the rooftop. I wish I had pictures of it. I can't show you the pictures because it'd give away who the brewery is. Um, I went to the roof and I found, and it was dead of winter. It was like snow up to your eyeballs. It wasn't heating. The makeup air units weren't reheating the air. It was blowing in Arctic air. Um, so I went to the roof to make sure that the controllers were working, and they were. And then I discovered when I opened up the units, and these units are huge. I opened up the units, and the actuators weren't on the hot water valves, or if there were actuators on the hot water valves, the actuator was frozen. Or if the actuator wasn't frozen, if you take everything apart, shut the unit down, take everything apart, you'll see that the piping, 1.5 inch, 2 inch pipe, um, was clogged up. I mean, you could barely move water through these things, so there wasn't going to be any water flow anyway. The insides of the coils were clogged up. The valves were frozen because of corrosion. If the valves were mounted, many of the valves weren't even mounted. So what we had was a maintenance problem. I was getting signal going to the valve. I could prove it. Um, I remoted into the system from the roof, plugged my laptop in, typed it up, and said, "Valve, I need you to stroke." And then I measured the voltage on the signal, and I was getting the signal. I was getting good signal. But what wasn't happening was the valves weren't moving. And it was a simple matter of the valves not even being healthy. The building was sick. What they had was a maintenance problem. Now, on the BAS side, um, this particular company has, I hate to say this, but they have a reputation of going into a system, doing 75 to 90% of the job and calling it good and leaving because they didn't bid enough on the job to complete the job. And that's when I usually got called in for this particular company to go and either complete the job or explain why it wasn't complete and then complete the job. In this case, this company and they're known for this. They use cookie cutter approach to programming, and what that means is they have a department that all they do is write the programs, and the programs are supposed to be customized once they're in the field to fit the application. But the guy in the field didn't know how to do that. He knew enough about the programming language to be able to install the program, but he didn't know how to do a point-to-point checkout. He didn't know how to do program checking or anything like that. So he didn't check the programs. So I spent a great deal of time rewriting the software. The physical BAS part was pretty good. They didn't have any wiring mistakes. I didn't have any a lot of communication problems. What they basically had was pretty bad installation and pretty bad maintenance. So that's something I ran into. Oh, and once I was flown out to the East Coast from St. Louis, and this great big warehouse it was a produce distribution warehouse, and on the roof was this gargantuan air handler, and they couldn't get it to work, and they were just pulling their hair out. They didn't know what to do. I got up there and discovered the BCIR card, the BACnet communication card, wasn't plugged in. It was that simple. I flew all the way out there just to find out they didn't plug in the BCIR card. I plugged it in. Um, logged into the system. I watched it go through its paces. I spent the day making sure it followed parameters and sequence of operation. I did the tug tests and all the wiring terminations, things like that. And it started working. I'll do one more here. Let me show you this. This is a picture of an alarm of an exhaust fan annunciation panel in a hospital in Houston. This hospital had a basement, a ground floor, 11 intermediate floors, a penthouse, and then a rooftop. And there were exhaust fans all up and down this place. So what the contract called for was that the building automation company that installed this was supposed to come out and put this panel in and get it to work so that if there was a fire, the fire department could come straight to this room and start turning on exhaust fans manually. That was the whole point, was the exhaust fans. And if you zoom in real close, you'll see they were on, auto, or off. And they would stay in the auto position until the fire department would come in and either turn them on or turn off the exhaust fan, depending on where the fire was. So I got there and everybody said, well, it's not working. We don't know why it's not working. Well, come to find out, the guy that bid this job bid for building this panel. And that's what they did. They built a panel. And that's the interior shot of the panel right there. This is another interior shot. I discovered when I looked at the wiring diagram that they didn't wire the controllers properly at all. So I had to unlace the harness and relace it back in. And it started working a little bit, but not completely. So what I found out was that the guy that bid the job didn't actually take the time to find out what's involved in making this work. This particular hospital had Allerton controllers, had Johnson controllers, it had Siemens, it had Distech, and I believe that's it. It had 4 different brands of building automation systems in it, and different areas and different zones and different floors were run by different companies. So at any given time, a Siemens guy could run into a Johnson Controls guy, could run into a Distech guy, could run into an Allerton guy, and they would all be working on the same floor because maybe half the hallway was Johnson Controls and the other half the hallway was, I don't know, Siemens or Distech or something. What they didn't take into account was this fire annunciation panel had to talk to every control system out there. They didn't think about how to integrate the control system. They just thought about building the panel, and that's what they bid on. They built the panel. They didn't take in consideration that, see this old, on the left-hand side of the screen here that I'm showing you, I'll zoom in on that. This is an old Johnson Controls graphical program, and it needed to be converted to the language that the panel, the fire annunciation panel, spoke. So we had to go from the graphical control program to the proprietary language that this control system that was monitoring the fire alarm system could speak to. They didn't even plan on doing that. And there were, oh my gosh, there were hundreds and hundreds of pages of programming that they didn't even bid on. So what I ended up doing was going through the entire system and adding, I had to add repeaters, I had to add translating devices that could translate Johnson Controls ArcNet into something that the other brand could understand. I had to be able to integrate all the different systems into a central location and have that central location talk to the fire annunciation panel. It became a middleman. So I had the fire control panel tell the central translator, we're going to do this, and then it would tell the Johnson Control exhaust fan, or it would tell the Siemens exhaust fan or the Distech exhaust fans or whatever exhaust fans come on or off based on what I did with the toggle switches. What should have taken a few weeks ended up taking over a year because the homework had not been done on this system. So what's the point I'm trying to make? I want to cover this, and this is really for the beginning. This is really for the beginning people. Um, this is for you. I want to show you some troubleshooting tips, if you don't mind. So basically, when I go out to a job site, first thing I remember is every BAS system asks and answers these 6 questions, and I'll show you what the 6 questions are. Question 1, do you want it on or off? Question 2, do you want more of it or less of it? Question 3, where do you want this to happen? Question 4, when do you want it to happen? Question 5, why do you need it to happen? It needs to make sense. And question 6, how do you need to make it happen? The how is a big part right here. How, and that's where the technician comes in. That's where the installer comes in. That's where the designer comes in. His job is to answer on or off, more or less, where, when, why. His job is to answer how it's done. So if you're not taking the fundamentals the point is take the fundamentals into consideration. So when I'm asking, I always go in, I greet the building owner. I talk, how are you doing? What kind of day are you having? I ask them a series of questions, but I base my questions on what I call the why analysis, and this is what the why analysis looks like. Let's imagine a problem. The car won't start. So why won't the car start? Well, the battery's dead. That's my first why. Well, why is the battery dead? Well, the alternator's not functioning. Why is the alternator not functioning? Because the alternator belt was broken. Why was the alternator belt worn out and never replaced? That's the fourth why. The fifth why is we didn't follow the manufacturer's recommended maintenance schedule. So what's the point of asking all these whys? I keep asking questions until I get to a process, because somewhere along the line, a process was overlooked. Somewhere along the line, they didn't take in consideration all the steps that have to happen in what order in order to have success. They left a step out, or they left many steps out, or they just got in a hurry. They didn't think about what would have to happen next. So I stop asking questions once I hit a process. We didn't follow the manufacturer's recommended maintenance schedule. 9 times out of 10, that's what I'm going to run across. Somebody didn't follow the manufacturer's recommended whatever, install it this way, maintain it this way, program it this way. There's a step that was skipped at the process. So I want to introduce what I call the troubleshooting mindset. And I developed this independently, but it was remarkably similar to a guy named Jason Maxim. He has a website called theartoftroubleshooting.com. He follows a very similar process for troubleshooting, and he is known as the troubleshooting guru. So sorry about that. What I do, I'm skeptical. No matter what people tell me, and no matter what I tell myself, I frame it in a way where I have to prove that the assertion is true or false. So I'm going to be skeptical about what's being asserted. I'm going to use all of my senses. It's not just what do I see, what do I think, what do I smell, what do I feel in the air, what do I hear. You can walk into a building and tell it's a sick building sometimes. You can just smell it, you can feel it. The air is stagnant, it's the wrong temperature, it's too humid, the indoor air quality is really bad, and that's usually a pretty big giveaway. I try to be organized, systematic, and detail-oriented and logical. I try to find creative ways to meet the end goal, and that doesn't mean that I go this way around my head to scratch my ear. It means if what isn't obvious doesn't reach out and grab me, I'm going to find creative ways to approach the problem until I find what's obvious about the problem. So don't forget to be creative. You give your full attention to the problem. Don't focus on anything else. Leave your iPhone alone. Put it in your pocket. Focus on the problem. Focus on the concerns. That way, you'll be able to solve the problem. You need to protect your time. Your time is you're being paid to be there to fix a problem. Probably by the time you got there, everybody's already angry and everybody wants a piece of your hide, and you had nothing to do with it, but you're the first guy that they have, you're the first opportunity they have to talk to about this. You set expectations. You let them know, I'm going to look into this. You guys are going to help me. I'm going to work with you guys to solve the problem. Set expectations and leave yourself an out. If you cannot solve the problem, you need to find a way to communicate that and solve that. Call a friend, call an expert, call the vendor, but leave yourself an out in case you run out of time and the problem cannot be solved. Let them know you'll come back. So I ask questions. I ask questions like, what is it doing? Or should it do that? I can't think of an example off the top of my head, but I ask them, what is the system doing that's being a problem, and should it do that? Or I ask, what isn't the system doing? Why is this not normal? I ask, when did this start happening? When did this stop happening? So maybe it started happening recently, or maybe it stopped happening recently and it's become a problem. By asking questions, you're going to get to the heart of what's really going on until you get to the bottom of the process. You ask, were there any recent changes in the environment? Did you change a set point? Did you override a set point? Did you manually adjust a damper that should not have been manually adjusted? Did you close a valve and lock it closed? Did something happen in the system that is not the way the system was designed? They may not know until you keep asking, till you go and point at it, look at it, and take it apart. The big thing to look at is alarms. Are there any alarms that reflect the nature of the problem? Are there any alarms that are secondary to the problem? Are there any alarms that are tertiary to the problem? This is important, and I'll get to that. Do you have history logs and trends? Will they be useful in helping you diagnose the problem? So let's get to the basic. Are all the conditions in place for a successful operation? In other words, is it plugged in? Did we change the belt on the alternator? Can I clearly define and communicate the problem? This is after I've done my analysis. I've looked and I've taken notes. I've taken a lot of notes. I've done my sketches. We've done a walkthrough. Can I clearly define and communicate the problem to the people involved, to my boss, to me, to whoever is going to be involved in the process? Has this happened before? Is the problem repeatable? If it's just now starting to happen, something changed to make it happen. If it's been happening intermittently, find out, see, that's a second. Has this happened before? Makes this problem a secondary problem because something else is going on that caused this to be a problem. So you need to be ready to ask that question. What makes the problem worse and what makes the problem better? And make sure you're not putting a Band-Aid on it. But what makes a problem worse and what makes a problem better? What has changed or is new in the system? This goes back to, has this happened before? If it's happened before and the answer is no, if it hasn't happened before, what's changed? What's new? What's different? Did you change the schedule? Did you manually override a point and you forgot about it? Is that sensor broken and you forgot to log it, or something happened? Then the question, have I looked at everything? There comes a point when you're looking into a BAS system where you think, I'm getting lost in the woods, too many VAV boxes, too many things to look at. But have you looked at everything that's relevant to the problem? You don't have to look at the boiler plant if the chiller plant's acting up. You don't have to look at the chiller plant if the boiler plant's acting up. So look at what is acting up and ask yourself repeatedly, have I looked at everything? Is the system operating beyond its designed limits? Does the system answer the 6 questions within the boundaries of its design? Am I trying to overcool by telling the chiller plant, instead of 55-degree water, I want you to put out 35-degree water. Instead of 45-degree water, I want you to put out 30-degree water. And the chiller plant is just jumping up and down inside the building. Is the system operating beyond its design limits? Have any maintenance issues been neglected? And this is a big one. Go back to that big baseball stadium. You saw all the wires hanging out of the gutter. Go back to this brewery. You saw negligence at this brewery. Now, here's where you need to be a diplomat. You need to work with the maintenance guys. You want them to work with you. You want them to be friendly. This isn't a competition, and you're not here to prove you're better than anyone. In fact, you're there to serve. Serving calls for a certain amount of humility, and don't forget that. Be humble. Go there to serve. You're helping them. You want them to learn. You want them to grow. And while you're at it, you're learning and growing too. So have the right frame of mind. Don't get an attitude with people. Maybe they have been hammering the crap out of their building and don't know how to maintain it. That is your problem because you're there to fix a problem, but it's not your problem to take over their training regimen. But you can educate people while you're working on the system. You can walk them through, this is my thought process. This is how I'm going to approach the problem. And buddy, if once we get this valve replaced, if maybe once every 6 weeks you check the system, grease this, change belts, check the valve, make sure it strokes. It could be just something they're not aware of. So if maintenance issues come up, don't get cocky and don't point fingers and don't lay blame. This isn't about laying blame. This isn't about making yourself look good. This is about solving a problem and being a solution for the problem. This is not about blaming. This is about solving a problem. And later you can do a post-mortem and you can politely suggest, I would like to recommend these following maintenance issues be addressed. That will help reduce a problem. And I'm beating on this for a long time. This is important. You got to build a relationship with these people and you got to learn to work with them. So do that. Can I reduce complexity? Sometimes I run into situations where complexity is an issue. It's over-designed, it's over-programmed, it's over-wired, it's overdone. The more a way to look at this is if you have a path that you have to follow and you have an endpoint that you have in mind, for every place that you have to stop and do something, I call that a node. The more nodes you put in between, the less likely it is you'll get from start to finish, unless you know how to focus. Complexity is usually what happens when people aren't sure what they're doing. So reduce complexity, make the program simple, make the solution to the wiring problem simple. A lot of times people just overwrite their program. They overdo their graphics. They overdo their thought processes. Simplify the problem. You'd be amazed how effective that is. If it's happened before, ask how they solved it last time. And maybe their solution is the right one. Maybe their solution is the wrong one, but you can find that out. A big one that I think you should look at is, have I checked my biases? And biases can come in any form. My boss told me this guy over here is a jerk, so I'm going to walk in with a bias. The guy is going to be a jerk. I will expect him to be a jerk. I'll treat him like he's going to be a jerk. He's going to be a jerk. Check your biases. Don't assume that you know what the problem is until you've done your homework. Don't assume that just because something's happening, that's the problem. It could be a symptom, not a problem. Make sure you've addressed the problem. And by asking the right questions, until you get down to a procedure, that's what you need to do. Until you find a procedural problem, keep asking questions, including your own biases. Remember, be cynical, especially with yourself. So will the repairs cause downtime? Who will be affected by the repair? How long will the repair take? What happens if it cannot be repaired in time? Have I made contingency plans? Have I kept the building manager informed every step of the way, or as often as possible, on what I'm doing and what it's going to take to solve the problem? What are the risks of repairing it? And I know it sounds crazy, but sometimes If you risk repairing something, you open up a can of worms and find out more things are wrong. And now that you've got this working, all these other pieces aren't working. I've had that happen to me, and this is common. Sometimes a symptom will mask a real problem. By fixing the symptom, suddenly repairing that symptom has revealed an even bigger problem. Can the repair be reversed? What if you decided this was a problem and you repaired it? Can you back out of that? Can you unrepair it? Have I documented every step in case I need to look back, in case I need to back out to where I started? This goes back, can the repair be reversed? Have I communicated with everyone involved? The important thing here is keep everyone informed, tell them what you're going to do, do it, and then tell them what you did. Document it, and let everyone know what you did, keep them informed, and educate them if it's necessary. When I'm finished, how do I know that I fixed the problem? Should I add redundancy? Does data exist that could be used to predict or prevent it from happening again? Would routine maintenance have prevented this problem? Is this problem the tip of an iceberg? Would I use this situation to make changes that would have been ignored otherwise? Was this failure intentional? And I'm going to talk about that. We hate to think that people would intentionally sabotage a building or a BAS system. We hate to think that, but it does happen. You have to ask yourself, was this on purpose? And I've seen this happen at a building in Houston, Texas. An employee got disgruntled. He was in the maintenance staff, and he was their lead technician, so he had full access to the building automation system. He got mad in the middle of the day, and I don't know if he was fired or if he quit, but he went home. He was able to remotely log into the system, and he hammered the system. We ended up having to restore the system from a backup, and it's fortunate that we had a backup. Until I came along to this particular building, they did not have any backups. So if this guy had messed the system up before we did backups, we would have been really screwed. So lesson one, is it intentional? If it is, you have a backup plan to restore it. Before you touch the system, back the system up. After you touch the system, back the system up. And in between the before and after, save. Okay? Can I set up the system so it'll alert the building manager before this becomes a problem again? Predictive maintenance is valuable. If I can let the building manager know, hey, this thing over here is about to happen again through setting up a series of trendings and logs and alarming, then he can address the problem, especially since we've taught the maintenance staff how the problem can be addressed and fixed. Have I documented everything? And I mean everything. First off, a year from now, you're not going to remember what you did today. So did I document it? Secondly, you may not be the guy that has to go back to this building. Does the guy going to the building have access to my notes? Have I put the notes where he can get to them? Have I taken good notes, or are they garbage? Take good notes. Don't let them be garbage. Put them where everybody can find them, and keep everyone informed. Have I communicated properly? And this goes back to keeping everybody informed. This goes back to educating people how the system works. This goes back to suggesting improvements. This goes back, communication, in other words, is vital. And my mentor used to tell me, give them the EEI, the essential elements of information. The essential elements of information are simply who did what, when was it done, why was it done, and how was it done. And that's it. That's basically it in a nutshell. Give them the essential elements of information. Let everybody know, this is what I'm going to do, this is what I'm doing, this is what I did. And detail it and document it. Is this an opportunity to train the end user? Before I leave a rescue, I let the end user, the building manager, know that For some reason, my camera has quit working. I'll let the building manager know your guys need an education, and this is how we do it. I simply let them know that we need to train your guys. We need to work with you guys. We need to show them how things are working. We need to show them what to do next. We need to teach them how to think about the problem. So I take the opportunity to train the end user. That's pretty much it. That's what I do when I go to buildings and see what's going on with them. One thing I'd like to encourage you to do is to go to our website, Smart Buildings Academy, and see if there's a program there that'll work for you. We have all kinds of programs at the Smart Buildings Academy. You can be a contractor that wants your people trained. You can get training for yourself. If you're a facilities professional, we have courses for the facilities professional. We have a program called Workforce Development that in 12 weeks can take you from zero to hero. We can take you from being somebody who serves hamburgers at McDonald's to being somebody who can be trusted with a laptop and a truck and can go out and do the basics of working with a building automation system. We have several steps and several ways to find out if the person will be able to get through the system. We're vendor agnostic, meaning we can train just about anybody. We develop core skills. We look at profitable execution. We teach people how to not waste time, but how to solve problems. We have several programs that you can see here: technician certificate, design certificate, sales certificate, project management, several resources. If you're a building, and we even have an area here, if I could find it. If you're let's see here, we even have free training resources for professionals. All kinds of skill assessments, webinars, and other things. So thank you for watching this episode. My computer's acting up now, so I'm going to stop. And if there are any questions, don't hesitate to call, and don't forget to look at our website, smartbuildingsacademy.com. I'm David Perkins, and I want to thank you for joining me on this adventure of troubleshooting skills and the adventures of a traveling BAS repairman. You have a good day. Bye.